In the past, we have discussed about vectors and how we can do the creation, subsetting, and other work with vectors. We're going to move on to another data structure in R, and we will be talking about matrices here. So with matrices, what matrices are is that they are like a table. So you can imagine a table where, say, we have a warehouse table. And I've already defined a warehouse table, and we'll be taking a look at this table towards the end, and we'll be creating this table. But here is the table that we'll be creating. So in this table, we have four of these columns here, and we have a couple of rows, which are also called records in this table. So this is a two-dimensional table where we have on the bottom going down is quantity sold. So, and on the top we have the element. So for the first element, which is say a computer. So in a warehouse, say we're selling computers. For the first computer, there are 100 quantities sold. There's 199 quantity imported. There is a sales price of 199.99, and there's a quantity left of 99. For the second one, same thing continues. Quantity sold is some quantity, imported is some quantity, sales price is some number, and the quantity left is some quantity. And this continues down for 6 elements. So let's go ahead and create this matrix. And one thing you notice here is every single element here is of the same data type. So if the quantity sold is integer, all of these others have to be integers as well. If it's numeric, it has to be all numeric. If they're characters, they're all characters. So keeping that in mind, let's go ahead and create our warehouse. So here we'll go down and do the correct matrix creation button. So we'll do warehouse, and we'll create it by doing a column bind, which is also called cbind, and we'll do cbind, do quantity underscore sold, then we'll do quantity underscore imported as the second column, sales underscore price, and then finally we'll do quantity underscore left. And the way that we find the quantity underscore left is going to be by defining it first, and we'll say quantity underscore left is equal to the subtraction of the sold from the imported. And with that, we have created our warehouse. If we get the same result out, we'll know that we have created our warehouse correctly. And you can see that we have now 6 elements down, and we have 6 records for 6 different computers. And here are what the records read: 100 quantity sold, imported 199, sales price $199.99, and quantity left as 99 quantity left. So that's a simple way of doing creation of a matrix by doing column bind. You can also do row bind. So say we had information on a bunch of these computers. So say we have something like comp 1, and we have comp 2, comp 3, and we'll do comp 4. And say comp 1 was composed of the following values. Say it had a quantity sold of 199, it had quantity imported of 780, list price of 98.89, and a quantity left of whatever the subtraction is going to be. And let's go ahead and do this definition here as well. We'll do C, and we'll just keep copying through and change the values afterwards. Let's change this to say 149, 69, 890. Okay, so now we're done creating 4 different computer products, and we can also do a row bind. So if we do R bind, and we do comp 1, comp 2, comp 3, and comp 4, and if we execute the creation of this, you can see warehouse is now defined to a new term, do warehouse to do a printout, and the output is computer 1 is assigned to 199, 780, and 98.89, and 199 is the quantity of the computers sold. This is quantity of the computers imported, and this is the amount of money for each of the computers. So we have created sort of a similar matrix as we did for the warehouse. So if we just rename this as warehouse 1 and warehouse 2, let's look at warehouse 1 side by side warehouse 2, and you can see that the matrix fundamentally is the same. Here in warehouse 1 we have quantity sold, imported, sales price, quantity left. Here is the same exact thing. We've just created these two different ways. The first way is we have sort of, if you think about say a GUI, and say you had 4 of these columns here, sort of dragged a column, placed it in this place, dragged another column, placed it in this place, and dragged another column, placed it in this place, and dragged the last one and placed it here. That's sort of how we've done. If you think about a GUI or a graphics user interface, which had, say, a couple of rows lying around, and the rows were like comp1, so we dragged that row, placed it here, comp2, drag that row, placed it here, 3 here, 4 here. So those are two different ways of forming a matrix, where one you do by column and the second one you do by row or records. Another way of forming a matrix is by using the matrix function, and if you do something like vector seq is equal to seq 1, 10, 3, and if you do vector seq to take a look at how this vector looks, we'll see how the one-dimensional vector looks like. It has 4 records. Now if you want to create a matrix out of this, you can just do matrix underscore seq and set that equal to, and we'll put a matrix function, and here we will place our vector, and we'll say the number of rows that we want is 2, and we execute all of this code now and do a printout as well. You can see that a matrix has been returned and it has 2 rows and 2 columns. So those are sort of 3 ways that we can do creation of matrices. One way is using different columns and then just tossing those columns together to form a matrix. The second way is by doing a row bind. Say you have different records and you want to place those records in a table, you can do the row bind. And lastly, you can use the matrix function. Say you have some sort of one-dimensional vector and you want to convert it to a matrix, you can just use the matrix function and define n rows, or you can also define n column, and you can say n column is equal to 2, and then it's going to fill by column. It's going to go down and say there are 2 columns and we want to fill those 2 columns, and then we also will produce whatever the other component is. Say this was 2, so 4 is the total number of the elements here, and it's going to do 4 divided by 2, and the rows is now going to end up being 2. With that, let's move on to the next lecture and discover some more functionality about matrices.